Hi all, this is Gaurang Tripathi from Test Automation Competency, and today I will be presenting the topic artifact management in the cloud in AWS, Azure and GCP. So moving forward, like as you all must be aware, but I want to repeat that we should follow the knowledge etiquettes, and lack of these etiquettes and manners is a huge turnoff. First one is punctuality, which means like we have to join the session 5 minutes prior to the session start time, and as we start on time and we conclude on time. Next one is feedback. So I request all that you should submit a constructive feedback for all the sessions, as it is very helpful for us as a presenter. Next is like you should keep your mobile devices in silent mode. I have also done it for mine and request you all to do it for yourself, and you are free to move out of the session in case you have to attend an urgent call. And the last is we should avoid unwanted chit chat during the session. So like today's agenda is we have to discuss about the test artifact management. So firstly, I will be briefing you through the definition of test artifacts, type of test artifacts, and importance of artifacts management. After that, I will walk you through the managing the artifacts using Azure, AWS, GCP, like how we can run our test on these and how we can generate the artifacts, basically, which are reports and logs. And then I will discuss the challenges we face in test artifact management and how cloud helps us in those challenges. And at the last, I will discuss future trends and innovations, and then we will have a quick demo. So yeah, so what are test artifacts? Basically, test artifacts are simply integral part of software testing, and these are nothing but the byproducts that are generated or created while performing software testing. And we need to record these test artifacts in proper manner with exact and accurate data or information and details, as a result of which it is very easy and simple to identify and track changes, and also be aware of the recent progress of activities of testing from requirement, as everything is recorded properly. So basically, everyone is using some tools and techniques for these artifacts creating and generating. So we will be using cloud to generate the artifacts. So basically, there are various type of artifacts which have their own purpose. So we have here the most common artifacts which are being used, like test cases, test scenario, test plan, test strategy, test reports, and test logs. Now talking about test strategy is generally prepared by test or project manager at management level, and it is outline or document that describes testing approach of the development cycle of software. Basically, it simply provides easy understanding of targets, tools, techniques, infrastructure, and timing of test activities, like which are to be performed. And it is also used to identify like all risk factors that can arise during testing and appropriate solution to reduce or mitigate the risk. So basically, test strategy is derived from business requirement specification format. Next, we have test plan. So test plan is detailed document which describes the software testing scope and test strategy, test deliverables, risk objectives, and activities. It is the most important and essential activity to simply ensure that there is initially list of tasks and milestones in baseline plan to track or identify project progress. So basically, it is used to identify the progress, like how of the testing which we are doing. And so it is a simply blueprint that explains how testing activity is going to take place in the project. Next, we have test scenario. So test scenario is nothing but it is a statement like which is used to describe functionality of the application or the software which is being tested, and it contains situations or conditions in application from which many test cases can be developed. So test scenario has one-to-many relationship with the test cases, which means that talking and thinking about requirements in detailed manner. Then we have the test case. Test case is a detailed document that describes cases which will help execution while testing, and it is documented, which contains test case name, precondition, steps, input, and everything, and expected results. So it is simply, in short words, we can say that it is simply a set of conditions or variables under which software tester will identify whether or not system under test satisfies the requirement or work in proper and correct way. Then we have traceability matrix, which is a matrix that contains tables to show and explain many-to-many relationships among requirement and test cases. This test traceability matrix generally help us to ensure transparency and completeness of product of software testing. Then we have software test report, which is generated as a process of testing, and it describes all the testing activities and provides the detailed information about status of test cases, test suites, or test scripts for given scope. And it is very much needed to represent the test results in the form of test report that gives opportunity to find out the results quickly. And at the last, we have test log file, which is a record of activities performed during the execution of software testing. So what is the importance of test artifact management? Like, why should we manage the test artifacts? So first reason is traceability and accountability. So the test artifacts, like like test plans, test cases, or scripts, they provide a documented trail of what is being tested. Okay, so like what it is being tested, it is given in these test plans, test cases, and test scripts, and how it is tested and by whom. So the traceability of these documents ensure that the testing activities can be linked back to specific requirements, and they help to verify that all the requirements are tested and providing accountability for the testing process. Reproducibility mainly means that the test artifacts enable tests to be repeated consistently. Like if we document these test cases and scripts, like team can ensure that tests are executed in the same way each time, so that we can reduce the variability and improving the reliability of the test results. And then well managed test artifacts, like if we are managing the artifacts well, then they contribute to efficiency gains. Like test cases and scripts, like which we have written or we have there, they can be reused across different testing cycles or projects, so which as a result will save our time and effort in test preparation and execution. The test artifacts also help in identifying and managing risk associated with the software under test by documenting test scenarios and expected outcomes. Team can prioritize testing efforts based on risk factors, ensuring that critical functionalities are thoroughly tested. Next, we have communication. So clear and well-organized test artifacts facilitate effective communication among stakeholders. This clarity will ensure that everyone involved in the testing process understand their roles and responsibilities. And then we have quality assurance. If you manage the test artifacts well, then it means that they are contributing to the overall quality assurance process. So if we maintain accurate documentation of tests and results, then teams can assess the quality of the software and make informed decisions about its readiness for release. At last, we have auditing and compliance. So documentation of the testing activities will help in audit and ensure that software meets the required quality and safety standards. So this documentation can only be done if we are managing the test artifacts effectively. So basically, in summary, we can say that if we manage the test artifacts effectively, then we can enhance the efficiency, reliability, and comprehensiveness of the software testing. So which will ensure that the testing efforts which we give are well documented, repeatable, and aligned with the project goals, which will ultimately lead to higher quality software releases. So now we will go with test artifact management in Azure. Basically, Azure provides several services that are relevant to test artifact management, so particularly in the context of software development and testing processes. So like here is an overview of some of the key Azure services that can be utilized. So for generating the artifacts, we have few services basically which are required. The first one is Azure Pipelines and Azure Repos, which come under Azure DevOps services. So Azure pipeline is nothing but it provides a CI/CD capability to build and test the script which you have, and it supports the integration with various testing frameworks, and that can be used to automate the execution of tests. Azure repos is similar to GitHub, like which will offer Git repositories for source control management and allowing us to store test scripts, configurations, and other artifacts related to testing. Azure Files provides a full managed file shares for cloud or hybrid scenarios, useful for storing shared test scripts or test configurations. And then we have Azure Monitor, like which is used to collect and analyze the data from test runs, providing insights into text execution and identifies the issues. Basically, if we use these services, then we are able to manage the test artifacts, we can execute the scripts to generate the reports and logs, and we can monitor them the entire process within a cloud environment, which will promote scalability, reliability, and integration capabilities. So let's see like how using Azure DevOps or Azure Cloud we can manage or generate test artifacts. So the first step, which is basic, like we need to have a Azure account. So if you haven't already, created an account, then we need to create an account where we will perform everything. After that, what we will do is we will upload the test scripts in Azure files. So basically here I have created Azure repo. In Azure repos, I have created a repo with the name demo. So where I am uploading my script, JMX script. So I have uploaded in the image. You can see that I have uploaded the script with the name REST API.jmx. So here you can also upload the script or complete project. Like if you want to run a Selenium test, then you can upload the complete project in this repo. Like it is similar to GitHub. After that, we need to configure Azure DevOps pipeline. So for that, we need to navigate to the pipeline section. In the image, you will be able to see, and then we have to click on new pipeline. After that, it will ask you to connect to the repository service, like which repository service you are using, like Azure repository, Bitbucket Cloud, or GitHub Enterprise Server. So I am using Azure Repos Git, so I've selected that. Then after that, it will ask which repository you want to select. So I have a repository with the name of demo, so I've selected that. After that, I need to configure a pipeline for that. So for that, we can select either starter pipeline or existing Azure pipelines YAML file. So for that, I have selected a starter pipeline. So when you will open that pipeline, you need to have that YAML. You need to define the YAML. So I have an example like where I defined the YAML. So it has few parts. So first part is trigger. So trigger basically specifies that when the pipeline should be triggered, like when the code should be built or start, when the pipeline should be started. So I have mentioned main, which means that whenever there are any changes in the main branch, so the pipeline will get triggered automatically. Then we have pool, which decides that our build will run on, our test will run on which agent or which virtual machine. So I have specified that it should be Ubuntu. So here Ubuntu latest specifies that the VM image is Ubuntu as operating system. Next, I have declared some variables for that, like test plan results report. So test plan is used where I am uploading my JMX script. And results is the name of the file where I will be storing my test results. And report, the folder where I will be storing the HTML report which will be generated. Next are the steps where I have written a script wget something and tar -xf Apache something. So first step is like here I am downloading the zip file of JMeter. Then I am extracting the zip file, and after that I am running the script through a command in bash, which is Apache JMeter dot the version name, and I'm going inside the folder. Then I'm executing my test. At last, I am publishing the test results, and which are basically the test logs, and I'm publishing the HTML report. So for that, I have used the task which is present in Azure. So I have used publish build artifacts, and I have passed the path to publish, so which will publish the test artifacts in artifact storage. This is an example like which is for running a Selenium test. So here again the trigger is pipeline will run automatically when there is a push in the main branch of the repository. Then I have named the job as Selenium test, and inside that I have specified the pool and the VM image, which is Ubuntu latest. After that, there are steps, a few steps which will be done for running our test and generating the artifacts. So first one is I'm installing a Java setup which is JDK 11 with 64-bit, and it is using a pre-installed JDK in that VM. Then I'm setting up the Chrome. So first I'm updating the package list. Then I'm installing wget, which will install the files and download the files. Then I am downloading the zip version of Google Chrome and installing it, and using this sudo dpkg command, which will resolve the dependencies. And after that, whether the Chrome is installed or not, for that I am printing the version of the code Chrome. After that, I am having the script which will run my Maven, or which will build my Maven. For that, I am using cd magneto, which will change the directory to the magneto and run Maven to clean the test and the project. After that, same thing, two tasks are there. First one will publish the log file from the Maven build to Azure DevOps artifact storage, and second one will similarly publish the HTML file to the Azure DevOps artifact storage. So as you can see that there's a condition always, so which means that whether my test above steps fail or they pass, in any of the case the artifact should be generated and should be published. Then we have different ways to publish the test artifacts. So we can use the task name publish test artifacts. So where we will be publishing the Azure DevOps, we will be publishing the test results and logs in the Azure DevOps portal. And if we use this publish build artifacts, then we will be publishing the artifacts in the artifacts tab. So we have used artifacts and build outputs in our previous example, you can see. So now we are moving to how we can manage our test artifacts in AWS. So firstly, we have AWS code commit. There are three services which I will be using in managing the artifacts using AWS. So first one is AWS code commit. AWS code commit is a fully managed source control service, like similar to Azure Repos and GitHub, that hosts Git repositories, and it securely hosts highly scalable private Git repositories and collaborate on code. So where we can store our source code or test scripts, and we can do our versioning for the same. So basically it offers three things, which is version control for test code, which means that code commit host Git repositories, like where we can store our test scripts, test configuration, and other code related to testing. Then it offers collaboration and integration, which means that we can collaborate these things with the CI/CD pipelines among team members and integrate with. We can trigger the builds and test based on changes pushed in the code commit repositories. And it also offers security and access control, which means that similar to other AWS services, like code commit provides fine-grained access control and integrates with AWS IAM, ensuring that only authorized users and systems can access your test code and artifacts. Next, we have AWS code build. So AWS code build is similar to the CI/CD which we have seen earlier in Azure. So it basically compiles the source code or your script, run the test, and generate artifacts without managing build server. This is the main thing for which code build is used. And we can automate builds and test in code builds. So basically code builds automates the build and test processes, ensuring that our test artifacts which are generated consistently. So this will help us in maintaining a reliable environment for running the test. Talking about the artifact storage, the code build allows us to specify the output artifacts which can be included in test results, like logs and reports. And these artifacts can be stored in Amazon S3 bucket, making them easily accessible and persistent. It also allows us multi-environment testing, which means that we can set up our multiple builds to run tests across different environments and manage the artifact generation in each context. Then we have AWS S3. So AWS S3 is an object storage service which is offered by AWS, and it provides scalable storage for a wide range of use cases, including storing and managing test artifacts. So first is flexible object storage. So basically S3 is highly scalable and durable. And this makes it suitable for storing large volume of test artifacts such as logs, test results, and generated reports. We can integrate it with CI/CD. So S3 can integrate well with AWS code pipeline, AWS code build, and other CI/CD tools. And we can store the generated artifacts during the build and test phases, which makes them accessible for further processing or sharing. We can also implement lifecycle management in S3, which means that, like, suppose we, like, it offers lifecycle policies like which automatically transition objects to cheaper storage classes and delete them after a certain period of time. So this will help in managing costs associated with storing test artifacts. Then how we can manage test artifacts workflow in AWS? So similar to Azure, like we can upload or store our code or script in AWS code commit and version control it, or any other code related to testing. Then we can integrate with CI/CD. We can integrate our script with the CI/CD pipeline to automate the build, test, and deployment processes. Like, for example, we can run tests using scripts from code commit. Then after that, we can use Amazon S3 to store artifacts generated during testing, such as logs, test results, screenshots, and performance matrices. Like, there are some points which we should remember while using code build. So we should define a clear artifact structure. Like, we should organize the artifacts in a logical structure, like separate directories for different test type to make them easy to locate and manage them. And in the build spec.yaml file in artifact section, there in the artifact section, we should specify like what needs to be archived or what needs to be extracted, like with like test reports, logs, or what needs to be extracted as an artifact. And we can directly store the test artifacts in Amazon S3 for durability and accessibility, as already told. And we can use versioning in S3 to keep the changes over time. We must also document the artifacts. This is the point that we should maintain documentation and what the artifacts contains and how it is generated and how it is used. So this will help the other testing team in understanding the process, and we can implement automatic cleanup to clean the old artifacts from S3 and save cost and maintain organization. And we can utilize environment variables while building our build spec YAML to dynamically manage artifact path, which will be easier and flexible to configure. So there are some best practices which we should follow while dealing with Amazon S3. So we should use separate buckets, like create dedicated S3 buckets for test artifacts, different buckets for logs or reports. We should enable versioning to track and recover like the changes or deletions. We should set lifecycle policies to automate transitions and deletions of old artifacts. Talking in terms of security, we should enable encryption, like we should use SSE S3 or SSE key management service or SSE to protect data at rest. And we should use HTTPS to ensure that data is encrypted when it is in transition state. And we should also set access controls to use bucket policies for high-level permissions and implement IAM roles for granular access control of S3 buckets. In terms of data management, we should configure cross-region relation, which will help in disaster recovery and redundancy. And we can use temporary credentials by employing AWS STS for short-term access to the bucket. And at last, talking about the compliance, we should ensure regulatory compliance and adhere to laws like GDPR or HIPAA by configuring appropriate policies and encryptions. Then we have test artifact management in Google Cloud Platform. So basically, we have few services which will help in artifact management in Google Cloud. So first one is Google Cloud Storage. It is similar to AWS code commit and Azure repos. The purpose of this is to object storage for any amount of data at any time, and like we can store and manage test artifacts like logs, test results, and other files. Then we have Google Cloud Build, which is a continuous integration and continuous delivery CI/CD platform, which is like it will help in building and testing the script or code, and can manage the artifacts produced during these processes. Like we can directly get the artifacts from while building these, and we can store them in Google Cloud Storage. Then we have Google Cloud Logging, like which is basically a centralized logging service, like which is used to analyze logs from various services, including test runs. And then we have Google Cloud Monitoring, basically which is a monitoring and observability service. And then we have Google Cloud PubSub, like which is used for messaging service for event-driven system. Like for example, if we set up PubSub to notify the team or trigger additional processing when new test artifacts are created. So basically, it is used for giving an alert if something is happening. Now we need to see that how we can run test and generate artifacts in Google Cloud Platform. So for that, first we need to upload the test file or project to Google Cloud Storage. So we can do this using two ways, using the Google Cloud Console or using the gsutil command. If you want to do it using Google Cloud Console, then we can directly navigate to storage and then browser and select the bucket which we have or which we have created, or we can create a new one and click on upload files and select the files or project from our local system. And if you want to use the gsutil command, we can open the terminal and we can use the following command to upload our files: gsutil cp path, which will be the path to our project folder or test script, and after that the bucket name where you want to upload that. After that, we can need to create a cloudbuild.yaml file in the project directory, and this will define the steps for the build process. So the build file will look something like this, and first we need to define the steps in our cloud build YAML, which will include steps to download the file from Google Cloud Storage, run the test, and then upload the test results back to Google Cloud Storage. After that, we need to trigger the build. So we can trigger the build or set up a trigger in Google Cloud Build to run this configuration file. Once the build is complete, we can view the generated artifact test results in your specified Google Cloud Storage bucket. So here is an example of how you can run a Selenium test in Google Cloud Platform. So first step is we need to, like it is downloading the Magneto folder from the Google Cloud Storage, for which first, like you can see names and ARGS. So name is uses the GST util builder, which is a command line tool for interacting with Google Cloud Storage. After that, ARGS specifies the command. It is a command which will copy the Magneto folder from Google Cloud Storage bucket to the local workspace. After that, we need to set up Chrome for running the Selenium test. So for that, we use an OpenJDK Docker image version 11 for Java application. Entry point here in the script signifies that the following things will be executed as a bash shell. Arguments contain a series of commands like similar to what we have seen in Azure, like updating the package list, installing wget tool for downloading files. Then we need to download the latest stable version of Chrome. After that, when the Chrome is installed, the dependencies are handled using the command, and then we will verify that the Chrome has been installed or not successfully by printing the version. After that, we need to build the Maven, for which we are again specifying the bash shell commands which will be running. So here cd magneto, the command is same. This will navigate into the Magneto project directory, and mvn --b clean test will run Maven in batch mode to clean the project and execute test. Then we will publish log files and publish extend report. So here you can see that we again uses the gsutil builder again, because we have to publish the log file back to the Google Cloud Storage bucket. In arguments, we will specify the command which will copy the log file generated from Magneto projects directly to the cloud storage bucket, and wait for use in the script ensures that this step waits for all the previous steps to complete before running. After that, we will publish the extend report, which will be similar to the previous step, like using the gsutil builder again, and then specifying the command to copy the generated file from the project directory to cloud storage bucket. But this time the file will be different. And last, the artifact section, we have artifacts which defines the artifact that should be stored after the build completes, and objects specifies the configuration of for storing objects, in which we have location, the cloud storage bucket where the artifacts will be stored, and path will list the files to be stored as artifacts, which include a log file and the HTML report. So here are some best practices which we should follow while using the Google Cloud Storage. The first one is bucket organization, which means that in bucket organization, basically we should use clear descriptive bucket names that reflect their purpose. And data structuring, like we should use prefix to simulate directories, like we should include versioning in file names or path to track different iterations of your test artifacts. And metadata and tags, like we should attach relevant metadata to objects to make searching and filtering easier, and we can use custom tags or labels for the same. Data integrity means that we should use checksum or hash values to verify data integrity, and we should ensure that the files uploaded have not been corrupted or altered. Access control and security basically deals in IAM policies and bucket policies, which we discussed in S3. So we can use Google Cloud IAM to control access, and for bucket policies, we can use uniform bucket level access to manage permissions at the bucket level rather than on individual objects. At last, we have data inscription, where we can manage and trigger action based on the generation of the test artifacts. For example, we can use set pubsub, notify teams, or trigger additional processing when new test artifacts are created. Now we will see the top 10 challenges in test artifact management and how cloud is helping them in resolving. So first is scalability. So we can see that as the project grows, like, and managing and increasing the number of test artifacts can become overwhelming or challenging. So for that, cloud offers a scalable storage and processing capability as the volume of test artifact increases. And these cloud services can easily scale resources up or down to meet demand, ensuring that test artifact management remains efficient. Next we have version control. So tracking different versions of test artifacts and managing updates can be complex, whereas cloud-based version control system provides centralized repositories with robust versioning features. Then we have consistency. So we should ensure consistency across test artifacts and environments, but this is challenging. So cloud platforms offer standardized tools and templates that help maintain consistency. Automate provisioning and configuration tools ensure that test environment and artifacts remain consistent across different instances and projects. Next, we have collaboration. So coordinating among geographically dispersed team members and stakeholders can be difficult. So cloud-based tools enhance collaboration by providing real-time access to test artifacts from anywhere. Features like shared repositories, real-time editing, and integration channels facilitate better coordinate and teamwork. Then we have traceability. So maintaining traceability between test cases, requirement, and defects is complex. So cloud management tools integrate with other cloud services like project management and defect tracking systems, by which we can seamlessly trace and link between different types of artifacts. Next, we have security and access control. So protecting sensitive data can be difficult. So cloud provides advanced security features including encryption, access control, and IAM. These features ensures that test artifacts are protected from unauthorized access and that sensitive information remains secure. So integrating with tools, in test artifacts can integrate with various tools, but this is complex, especially in diverse environments. So cloud platform often supports a wide range of integration with other tools such as CI/CD, test automation tools, and defect tracking systems, which will facilitate a smoother workflow and data synchronization. Then we have cost management, that managing costs associated with storage and processing of test artifacts can be challenging. So cloud services offer flexible pricing models like such as pay as you go for reserved instances. So which then we have backup and recovery. So ensuring reliable backup and recovery of test artifacts is complex these days. So for that, cloud provides typically offer automated backup and disaster recovery solutions, as we have seen. So regular backups and easy recovery options ensure that the test artifacts are protected against data loss and can be quickly restored if needed. At last, we have maintenance and compliance, which is challenging. So cloud solution is to, like, cloud provides offers have built-in compliance features and certifications. Example like GDPR, HIPAA. So by leveraging these features, organizations can ensure that their test artifact management practices comply with relevant regulations and standards. Let's talk about the future trend and innovation. So what are the emerging trends of test artifacts? For test artifacts, first is integration with CI/CD pipelines. So test artifacts are becoming integral to CI/CD pipelines, and this integration helps in tracking and reporting of the test results, by where we can get the real-time insights of the script or the code which is being tested or deployed. Then test artifacts are now being version controlled, so with the help of which we can manage the changes in the test cases, data, or results for the future. Automation and AI integration. So like the use of automation and AI in managing test artifacts is on the rise. So nowadays we have AI-driven tools which can automatically generate test cases, analyze result, and even predict the potential defects based on the historical data. Increased use of test data management. So there is a growing emphasis on managing test data effectively. Like test artifact management tools are being used to create, maintain, and provision data that are realistic and relevant to other scenarios also. So collaboration and centralization, which we talked. So here cloud supports the centralized repositories for the artifacts. So this trend is focused on creating a single source of truth for all the test related information. At last, we have enhanced reporting and analytics. So advanced reporting and analytics are being used nowadays to provide deeper insights into test results. So these tools help in identifying what are the bottlenecks and area of improvements in the testing process. So how are the cloud platforms evolving to meet the needs? So first, unified platforms. Cloud platforms are increasingly offered unified environments that integrate various aspects of test management. Like in a single cloud platform, we can do test planning, execution, and reporting, as we saw in Azure DevOps or AWS and Google Cloud Storage. Scalability and flexibility. So with the help of cloud, we can provide scalable resources for running quite large number of tests and handling diverse test environments. Then we have enhanced collaboration tools. So cloud-based test management tools often include features that facilitates, like we can have real-time collaboration and we can share our dashboards, comment section, etc. Advanced data storage and security. So cloud provides scalable data storage solutions. This include encrypted storage for test artifacts and compliance with various data protection regulations. We can Many cloud platforms, like we are designed to integrate seamlessly with existing DevOps tools or workflows. So this integration supports automation of test artifact management as part of overall CI/CD process. At last, we have machine learning and AI capabilities. Cloud platforms leverage machine learning and AI to enhance test artifact management, like which we saw that it can be used for predictive analytics or test results and anomaly detection and automated test case generation. Now we will move towards a demo. So in the demo, basically, I will show you how we can run the script from code build and store our generated artifacts in S3 bucket. So let me clean it before. So this is my S3 bucket. So where the artifacts will be stored. So here I have created a build. So let's see how the build is created. So while creating a build, like we need to give the project configuration, like the project name. So I have given the project name as demo. After that, we have to give a source. So we can give a source as Amazon S3 code commit. Like in the PPT, I shown that we can use AWS code commit. We can use GitHub, Bitbucket, GitHub Enterprise, GitLab self-manage anything. But currently, I am having my code on GitHub, so I'm using GitHub. Then we have to give the credential, a default source of credential or custom source of credential. So here I am using default source of credential. Repository in my GitHub account, or it is a public repository or GitHub scoop webhook. So I'm having the repository in my GitHub account. Then we need to give the link of the repository. After that, we can also give these additional configurations, but I have not given. Then we need to give the environment, like where you want to build infrastructure to respond. So I've given the on-demand model, and it will ask for the environment image, like which image on which VM it will run. Like you want to custom image, specify Docker image, which image you want to. So I have used managed image, which is using an image managed by AWS code build. So I'm using a EC2 instance, which will optimize the flexibility during the action of runs. Operating system is Amazon Linux. Runtime is standard, and image of the Linux is standard 5.0. I've already said I always use the latest image for this runtime version. Then we have a build command. Like we can either give a build spec file, or we can insert the build commands. So these are the build commands which I have entered. So basically, environment is the same as the variables which we gave for the test plan. So test plan is my script. Test script results are the results.jtl, where the logs will be stored, and report is the folder. I've created a folder report where the report will go. Then we have phases. First phase is install, where installation will be done. So this I have done for demo. Like you can ignore this. So we can directly come on commands which are used, like echoing install wget and tar. Like we can ignore basically. So this is the commands which is used to install wget and tar, like which will be used for downloading the JMeter. So if we will see pre-build, we have commands like echo downloading Apache JMeter. So this will print downloading Apache JMeter. And as we have installed wget, this will install the zip file of the JMeter. After that, we will extract this JMeter from the zip file, and we will have the application of the JMeter. Then we will run the JMeter test using the command line, and after that we will post build commands. We will have the commands for publishing the test results and HTML report. At the last, it will move the artifacts generated to the S3 bucket. So basically, after that, in this we have artifact section, where we can select like where you want to have the artifacts. So I am selected Amazon S3. Then we need to give the bucket name. the name of the folder where I want to have the artifacts I given demo. And the path is optional, I have not given. It is asking whether you want the artifacts in zip format or as it is, so I have given as it is. I have disabled the artifact inscription, and CloudWatch logs is optional. Like if you want, you can, otherwise they are not required. And then we will read a service role. Basically, service role is required for generating the build. So like this build was created, so I will start it again. So we can see the logs here also, like CloudWatch logs, like what is going on in the build. You can see that running JMeter test. Post build state succeeded, uploaded artifact state succeeded. So if we'll go here, like we will refresh. So inside this, we have got our artifacts which we can download and view. Yeah, so that's all from my side.
Thanks, Gaurav. Guys, do we have any questions? Anybody,
Okay, if
any questions?
anyone has any questions, they can ask.
All right, then we'll take it as a no. So thank you so very much, Gaurav, for the wonderful session. And thanks everyone for
No,
attending this.
Bharti.